Okay, record. There we go.
If a train crews out of the meeting,
Pull up a coffee and we're ready. All right, 6:30. We'll get started. This week's code of conduct item is to maintain respectful behavior whenever one is working, driving company vehicle, or wearing company logo. You're always representing the company when you have our name out there. And took a look around, Matt and I did before the meeting, and said it looks like everybody's got nice, clean, sharp-looking vests too. That's part of looking respectful and behaving respectful is looking and being very visible. Obviously, has an advantage. We had such a clean, perfect vest display here. Matt will be talking to you after the meeting. All right.
I gotta see you after the meeting.
So let's see. We're going to talk about rigging and signaling here in a moment. Corporate announcements, vehicle registrations. There's still, I'm sure, plenty to be picked up.
As many as there was last week.
So let's check it out and get on it. Last thing you want to do is get stopped on the roadway and say, yeah, I was supposed to pick that up at Larry's shop and I forgot. I don't think that excuse will go very far. One thing I haven't included, I'll start including here, is a reminder to start winterizing or thinking of winterizing.
Yes.
Maybe this weekend even is supposed to get cold. So I would say anything with water in a small quantity especially. I think that, big tanks and everything are really a problem, except maybe in the valves, but
all the pumps.
All the pumps, certainly. Pumps are an issue. So keep that in mind. It's going to get more and more important here. Technical tips this week. Again, we're talking about fluid mechanics and pumps, actually. So talking about selecting a pump this week. And we've talked all about flow and head and everything. So now we got a little more sense in volume, what volume is, how it's measured and everything. So let's say we had that case last week where we had flow through a stream and we could estimate based on the height and width and the speed of a twig flowing through what the volume is. I made up a new number that's a little more practical. So how do you go about deciding how to select a pump? In this case, I have 4,000 gallons a minute, and 100 feet we're going to pump it right up a pretty long bank, but that can include your head losses. So as we discussed last week, I guess not all that much, but as things flow through a system, they lose some of their energy, and we got to make up for that in the pump selection. And sometimes, of course, we're sucking it up. If it's a submersible pump, there is no suction. It's in the column of water. It pushes it all out. But non-submersibles obviously have to suck it up into the pump system. So there's obviously a lot of pump options available. And in the case of pumping something like that at that kind of volume where you have suction especially, we would think of a self-priming centrifugal pump. And the self-priming capability allows us to pump in so-called dry case, which I want to talk about a little more without damaging the pump. And then you would find that these size flows and head requirements require something like a 12-inch pump. And this is from Godwin Pump for a 12-inch diameter on their performance curve. And we'll look where we have the head of, well, this is meters. Okay, it's hard to read on here. There's 100 feet. And flow right around a 4,000. And they have their chart set up for different RPMs on the engine. And the idea behind picking a pump is not to go, oh, look at that, we can get out there to 6,000 at 70 feet, 75 feet, because you're going to really tax everything and you probably won't have a successful dewatering system. So you want to pick something back in the mid-range, maybe the upper beyond middle range. So 4,000 here and 100, it brings us right to here. So we'll be running a little more, and it looks like 1,600 RPMs. And then, of course, we've kind of selected things conservatively, so hopefully we're working on this side of the curve. But you certainly don't want to be picking at the limits of your curve, just like everything, just like picking rigging. We don't want to go pick a shackle good for 8,000 pounds if our load is 7950.
A lot of those pumps too, they lose their prime if you suck it down. And even the self-primers, you get some static up there, so it builds back up. So
well, that was an important thing. Well, let me just finish this. From the pump curve, you can see that this pump is working well below its maximum. In general, that's where we want to be. Now, the point about self-priming pumps, you have to have water in there to start with. You don't just drive up, especially this time of year, if we've drained the pumps because it's potentially going to freeze overnight. You still have to get water in the prime system. But a self-priming pump, if it's running, you wouldn't have to winterize it, because if you got it attached to the water, and even if it's sucking air, it's got water in it, it's stirring up the water. But you can't run a self-priming pump dry, meaning totally without water in the system. That will burn it out. And I did attach a link to the spec. So for this week, I'm going to talk about, on projects, the Shoreham Route 74 bridge. And we're contracted with the V-Trans to perform repairs to the concrete piers and the steel girders on the Shoreham Route 74 bridge over the Lemon Fair River. And the bridge consists of a 3-span concrete deck with steel girders, and each girder is a simply supported beam, except the top flange is tied in. So you can't really see. I think the next picture you can see what I mean by, no, you can't really. Well, I guess you can. Concrete pier, and the girders come in, and they're not attached. However, they're attached to the deck, concrete deck, so they're kind of attached, but they're not truly a simply supported beam, which is a kind of beam, so that theoretically this one is working separately than the adjacent one. So the pictures here show us, actually we're mag drilling. It's hard to see in the picture. Mag drilling some bolt holes for new plates, and we're attaching plates to the ends of the girders around the bearings to stiffen up and to reinforce the web. On a beam, the load is transferred into the web in shear, so it's holding that up. The load is on there, and that area is highly sheared. As you go away, the shear typically reduces because of the loading, and then you start to get bigger moments. So your flanges are working away from the support. At the support, it's all about shear, which transfers through the web. And did anyone else think that was kind of an odd photo of Paul Brunton there? Or just not sure what he's drilling holes. Yeah, he's got the right posture on, I guess, so. Right, doesn't he? Got the right pushing with his legs, it looks like. So that's what I got. The blog was just primarily gives you a link to some signals, for hand signals, for crane signaling. And just the point that I made here is that it's important to have those signals and know them and be doing the right signals and being coordinated with the crane operator. And it's pretty much the hand signals in this OSHA link is what you use for crane. Excavator use is different. Even though it's lifting, you're not hoisting with like a cable. You are basically, the operator is lifting the machine. So my example about why it's different for an excavator is because if you were telling a crane operator to boom out, he would boom out. But if you're talking to an excavator operator, well, there might be cases where you want him to boom out, but what are you talking about? The dipper stick, the boom, and it's all an articulated configuration. So you just tell him to lift up, and he knows, and he's got the feel of lifting up. So he's got a different level of control over the stick and the excavator than the crane operator has. More simple single direction moves, which the signal man can control. And I do have, like I said, I had a link to which I'm sure that Matt's going to show us more on, but there's a link from OSHA of all the hand signals.
Mm-hmm.
Okay, Matt?
Yeah, those are all the approved signals. We'll go over other requirements for crane, but also just for general purpose. You know, you can use some of these for, for just spotting and things like that. But the biggest thing with signals is all about communication. All right, a good pick, good crew is on the same page with good communication. So it all starts with the planning process. With cranes, if you're going to work on a crane, you got to go through training. To become a signal person, you got to go through a little course and understand a lot of these signals that we're going to go over. But it all starts with the pre-planning, like we talked about last week, having the right personnel, who's the dedicated signal person for the crane. The only time we really need a signal person is when the crane operator, or you can say excavator operator as well right now, loses sight of their load. Can't see the hook, can't see the rigging, can't see what they're picking. Once he loses sight, then we need to have a signal person there to help guide, place this piece of pipe, box culvert, whatever we're setting in place in the right location.
Regardless of whether they're in sight, that the crew on the ground that's doing the rigging has to acknowledge that the rigging is complete and it's ready for the lift.
Yes.
So that signal is, you have to do that.
Yeah. That's all the pre-plan and make sure everything. That's kind of the pre-plan, like lift it up 2 inches, make sure everything's square.
Right. But until that, that is at least a signal saying,
yeah,
lift, or whatever.
We're good to go.
We're good to go.
Yeah. 2 types of signals. We're going to go over the hand signals. I got a short video we'll watch on hand signals, and the other one, and the more preferred method, is voice. It's really direct contact with you and the crane operator. It's a better technique if we have it. If we can get radios or the headsets when we use in Rygate. So with voice communication, there's 2 types. There's hardwire, which we wouldn't really use, but of course the radio. And a couple things with the radio is we want to make sure there's no interference. We have direct contact. We don't want to have out there our crane operator and our signal person hearing the flagging operation that's going on the roadway. So we want to make sure that we're on our own signal. There's no interference. It's really reliable. And we always want to make sure we have open lines of communication back and forth between those 2 operations. Again, repeat commands. OSHA, they kind of like to make sure we discuss the signals, voice signals, if we're going to use boom, hoist, lower, whatever we're going to do. But they also like to see, I think I have it in here, yes, it's distance and direction. So if you want to have the crane operator swing 40 feet, Jim, swing over 40 feet, tell them 35, count down 35, 30, 25, 20, slow, and you can start slowing them down as you start getting closer to and then you tell them to actual stop. Again, a lot of times if he can see what he's doing, you don't have to go through this, but if he's blind, then you need to make sure you really have the proper voice communications. Function, direction, distance, and speed. That's what we really like to see. It's a really open lines of communication where you're really covering all your bases. And then function to stop. Test the equipment before we get out there. Make sure our operators, ideally, it's hands-free for them, so they got both their hands on the joysticks and they'll be able to talk clearly with the people on the ground. So hand signals, before we get too far into it, I got a little video I wanted to show here. But before I show the video, I just want to go over, I'm going to show you the approved signals for, from OSHA, the ASE, the CCO, all the crane institutes out there. These are all approved. We can have our own signals, but we just need to make sure that the crane operator and the signal person. So you see a lot of this out there, this is a lot of universal for stop for, a lot of times. Well, this is not approved hand signal. So if you're throwing this signal out and the crane operator is not stopping, okay, then we're not on the same page. You want to make sure that yourself and the crane operator are on the same, because, more and more these booms are in the air, we're going to see more and more compliance officers on. And this is some of the low-hanging fruit where they're going to look for, because they're just getting trained in all this stuff right now. And the hand signals might be one of those low-hanging fruit that they might try to cite a company on. So let's not let them do that. Let's make sure that we have documentation of our hand signals that we're going to use.
Or this doesn't really mean much.
Yeah, but you see it, you know, slow
Yeah,
down.
but you don't know
yeah.
if it's
Yeah,
moving down,
moving
or,
down,
or
yeah.
flooring.
Lowering people down. Yeah, so make sure it's agreed upon in advance. We also have a pre-pick checklist, and a lot of that stuff is right on that. It's right on the shared drive. I could show that, and I've been sending that and make sure that all of our crane sites have that pre-pick plan. So some of this is the last check all that we're covering through all of our bases before we do any lifting. So at that moment, let's go ahead and watch this little video on cranes. It's a pretty good video.
'Twas the night before Christmas, and all through
with arm extended downward, forefinger pointing down. Move hand in small horizontal circle. Transition to stop.
Now it's the lower.
Use main hoist. Tap fist on head, then use regular signals, such as the hoist signal, to stop. Use whip line, which is auxiliary hoist. Tap elbow with one hand, then use regular signals, such as hoist, and then transition to stop. Raise fingers closed, thumb pointing upward, then transition to stop. Lower boom. Arm extended, fingers closed, thumb pointing downward, then transition to stop. Move slowly. Use one hand to give any motion signal and place other hand motionless in front of hand signal giving the motion signal. Hoist slowly is shown as the example here, but it also works with boom up, or raise boom, or lower boom, or swing. Swing in the direction indicated slowly is a signal given here, then transition to stop. Raise boom and lower the load. With arm extended, thumb pointing up, flex fingers in and out as long as movement is desired, transition to stop. Lower fingers in and out as long as load movement is desired, then transition to stop. Swing. Arm extended, point with finger in direction of swing of boom. Doesn't matter which arm you use, the operator is to swing in the direction indicated, and then transition to stop. Emergency stop. Both arms extended, palms down, move arms back and forth horizontally. Travel. Arm extended forward, hand open and slightly raised, make pushing motion in direction of travel. Dog everything. Clasp hands in front of body. Travel both tracks. Use both fists in front of body, making a circular motion about each other, indicating direction of travel, forward or backward. Travel one track. Lock the track on side indicated by raised fist. Travel opposite track in direction indicated by circular motion of other fist, raised vertically in front of body and in the direction indicated. Extend boom. This is for telescoping booms. Both fists in front of body with thumbs pointing outward. And transition to stop. Retract boom for telescoping booms. Both fists in front of body with thumbs pointing toward each other. And transition to stop. Boom. Telescoping boom. One hand signal, one fist in front of chest with thumb tapping chest. Transition to stop. Retract boom for telescoping boom. One hand signal, one fist in front of chest, thumb pointing outward, and heel of fist tapping chest. Transition to stop.
So those are the basic signals. That's the proof signals that we should be using out there if we don't have anything agreed upon before. Is there any questions with those? Those they can get a little difficult if you don't use them all the time. That's why it's important that we always try to select one person out there, kind of work with the crane operator, because it is difficult at times to remember all that stuff. But it's a good visual of how it's supposed to be. Those signals, all of them, are listed on the crane itself, so you can always go back and reference it inside the crane to look to see, make sure that we're all on the same page. Biggest thing is with the signal person, we want to make sure that that person kind of stands out a little bit, so, wearing maybe like a class 3 vest or a different color hard hat, something like that, if there's a lot of people around. But again, make sure it's just one person. We don't want to have a million people. The same thing with your crane operator, with spotters and stuff like that, or your excavator operator. There should only be one person doing hand signals. We shouldn't have 4 or 5 people telling the operator to do one task, because there could be a lot of some confusion and some miscommunication happens, and then there could be an accident or a utility strike or something like that. So make sure it's just one person out there. And then again, the crane signals. If anyone wants a printout of some of this and is very interested in this, I have plenty of documentation and love to start seeing more people, using this not only with our crane but also with excavators. There's, the crawler one with move-in is a great visual to help the operator position himself in tight quarters. We have a lot of near misses or small property damage because working in tight quarters due to our work, where we can really use some good hand signals sometimes, because it is loud, a lot of heavy equipment, a lot of high RPMs being used where we can't hear each other, where hand signals is a good tool to make sure that we don't have any property damage or near misses and hopefully any accidents out there. Is there any questions?
I think that one thing that is reasonable for us to do when we're working with the cranes is just guide them to get the load off the ground and away from the guys. And then whether they boom up or hoist up after that in their turn is really more something the crane operators will know and be better at controlling. But most of our operations are just getting it up and then at the receiving end, getting it down in the right position.
In the right place, yeah, I agree.
Okay. All right, good. Back to Wayne. Run.